Hello to whom it may concern. Today, we are going to explore a very interesting and fundamental topic in computer science, algorithm and flowchart. These two concepts are the foundation of programming and problem solving, which is also the motive of this YouTube channel. These concepts help us plan solutions before we actually start coding. An algorithm is a step-by-step procedure to solve a specific problem. You can think of it as a set of precise instructions that, when followed, will lead to the desired solution. For example, if we want a computer to find the greatest of three numbers, we must first describe the steps it should follow to compare and find the largest.
To make this easier to understand, let's consider the analogy of cooking a vegetable dish. When you cook, you follow a set of ordered steps, like going to kitchen, washing the vegetables, taking a plate, chopping vegetables, placing a pan on an induction stove, connecting the induction plug to the power supply, heating oil, adding spices, and then cooking until done. Now imagine if we mix up the order, say, cutting the vegetables first, and then placing them in the plate. The vegetables would just get contaminated. That's exactly what happens when steps in an algorithm are not properly ordered. The outcome becomes wrong or meaningless. That shows why the sequence of steps matters so much. Each step must be done in a particular sequence. If you skip or mix the order, the result won't be right. Similarly, in an algorithm, each step matters, and the correct sequence ensures the correct output. Can you see the red button? Yes, I pressed it. It wasn't supposed to be pressed. Pressing it turns off the induction. There's a scene like this in the comedy movie Demal or the older classic It's a Mad, 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 Mad World, where giving ambiguous instructions leads to chaos. This example shows that in an algorithm, every instruction must be clear and unambiguous. There should be no confusion about what each step means or when it should be done. An algorithm is fundamentally made up of three basic building blocks: sequencing, selection, and iteration. Sequencing refers to the execution of instructions in a specific order, one after another. It ensures that operations are performed step by step as intended. Selection allows the algorithm to make decisions, choosing between different paths or actions based on certain conditions. It involves conditional branching, like if-else constructs. Iteration is the repetition of a set of instructions either a specified number of times or until a particular condition is met, commonly implemented using loops, such as for and while loops. These three constructs are essential because they provide the foundation for creating any algorithm. By combining sequencing, selection, and iteration, complex problems can be solved systematically and efficiently through algorithms. A good algorithm should have the following properties. It must have clear and finite steps. It should produce the correct output for valid inputs. It should stop after a finite amount of time. It should be efficient in terms of time and resources.
For example, if we want a computer to find the greatest of three numbers, we must first describe the steps it should follow to compare and find the largest.
Step 1, start. Step 2, read values of A, B, and C. Step 3, if A is greater than B, then go to step 4, else go to step 5. Step 4, if A is greater than C, write A is greatest, else write C is greatest, and go to step 6. Step 5, if B is greater than C, write B is greatest, else write C is greatest, and go to step 6. Step 6, stop.
A flowchart is a diagrammatic way of representing an algorithm. It uses symbols and arrows to show the flow of steps in a process. Flowcharts make it easier to visualize the logic behind an algorithm. Common symbols include oval for start and end, parallelogram for input and output, rectangle for process or calculation steps, diamond for decision or condition checking, arrows to show the direction of flow.
Here is the same example that we used in algorithm, but it is more easy to understand. A wise person once said that a picture is worth more than 1,000 words. An image can communicate the essence of a complex idea more effectively, deeply, and quickly than a lengthy textual explanation or words alone.
In the next few videos, we will learn how algorithm can help us solve a problem like the one currently on the screen, which is used to find the path that would take minimum time to travel or to find the shortest path.